Hello, dear students. Good afternoon to one and all. Good afternoon, Anita, Mahek, Sanika. Good afternoon to all of you. So, can you all able to hear my voice? Today, I'm not able to turn on my video due to some poor internet connection I'm facing here. So, I think all of you can able to hear my voice, right? And all of you can able to see my screen now. Just give me a thumbs up or put a yes in the chat box. Can you all able to see my screen and can you all able to hear my voice? Yes. Okay then. Okay, fine. Okay, students. So today will be the last class for this chemical kinetics. So, so far in the last two classes, we have discussed the some questions, some level 1 questions and level 2 questions of this lesson. So today we are going to look into the previous year's questions of JEE and NEET from chemical kinetics. Okay. So keep a notebook pen with you. So today we are going to solve many numericals. Okay. So for each question which we are going to solve today, I will be giving you some time. Okay, like 1 minute, 2 minute time I will give you to solve each and every question. And if you have solved within that time limit, you can put the answer in the chat box like you have been doing in the last class and before that. Okay. So after that, we will discuss that particular question in the class. Got it? So let's move on to the first question for today. So here is the first question. For a reaction 3A giving 2B, the average rate of disappearance of B is given by del B by del T. The correct relation between the average rate of disappearance of B with the average rate of disappearance of A is given in option. So the rate of appearance of B is given. We have to find out the correct relation between the rate of appearance and with the rate of disappearance of A and B. So all of you try to solve this. I want all of you to solve this. Keep a notebook with you, keep a pen with you and try to solve this in your notebook and give me the answer in the chat box. It is very easy. You need to write the rate equation for this reaction and then you have to relate. That's it. All of you try for this. All of you try for the answer. You can take 1 minute to solve this question. Let me know the correct answer in the chat box once you're done with this. Anita is getting option B. Anika is getting option C. Okay. So which is the correct answer? Two options are given like this. So once again, both of you check your answers. Both of you check your answers and check whether the answer given, the options given by you is correct or not. Try once again. Try once again. By the way, others also try. Try and give your answers in the chat box. Akshi is going for option B. Okay. Others. Jyoti B. Anika is saying it is wrong. Which is wrong, my dear? B is wrong. Which one is wrong, you're saying? Okay, we will solve this question now. All of you listen. The rate equation for this given reaction is, so with respect to the reactant, it will be minus 1 by 3 del A or dA by dt. But here we have Let me erase this. Here we have del. So let me erase this 3 and go for del. So it is minus 1 by 3 del of concentration A by del T. So which is equal to plus 1 by 2 del concentration of B divided by del T. So this is the rate equation, right? And if you bring this 2 to the other side, it will go to the denominator. So minus 2 by 3 del A by del T is equal to del B by del T. So the rate of appearance of B is given by this del B by del T. We have to find out the correct relation. So it is equated to minus 2 by 3 del A by del T. So which is the correct answer? Option C is the correct answer. So can you all able to understand? So that is a small mistake you all have made. You have put the numerator in the denominator place and denominator thing in the numerator place. So students, you should be very, very careful. Okay. A small mistake, silly mistake will lead to the wrong answer and it will fetch you the wrong answer. Okay, it will go with the minus. So don't do that mistake. Now I think you all have got the point. So shall we move on to the next question? Is it clear? Is this question clear to all of you? Yes. Okay. Okay, dear. So here is the next question. The correct options for the rate law that corresponds to overall first order reaction is the correct options for the rate law that corresponds to overall first order reaction is. So you have to find out the overall order of the reaction as 1 from the given 4 options. Which is the correct answer? Sakshi B, Rutuja C. What about others? Sakshi have deleted. Sanika is going for D. So, how to find out the order of a reaction? How to find out the order of a reaction? The sum of the powers, right? So, for option A, if you sum up the powers, what you will get? What is the order? You will get if you sum up the power. We have 0 and 2. So, the total order of the reaction is 2 for option A. But we are asked to find out the one which is having the order as 1. So in the second case, the order is equal to A1, B1. So 1 plus 1 is again 2. And here 1 by 2 plus 2. So what it is? 5 by 2, which is equal to 2.5. Okay, and here we have minus 1 by 2 plus 3 by 2. 3 minus 1 is 2, 2 by 2. So the order is 1. Got it? Which is the correct answer? Option D is the correct answer. So just add the powers to find out the order. And, you will get option D as the correct answer for this question. Okay. Shall we move on to the next question? This one is very easy. So we'll move on to the next question. For a certain reaction, for a certain reaction, the rate is equal to K into concentration of A to the power 2 and into concentration of B to the power 1. When the initial concentration of A is tripled, keeping the concentration of B constant, the initial rate would. We have solved this type of question though in the yesterday's session. So try to apply the same concept and get the correct answer, and let me know the answer in the chat box first. Take a minute to solve this question. Just saying option A. Let's wait for others. It's also Rutuja and check whether your answer is correct or not. Kanika is also going to A. A is not the correct answer, my dear students. So check your answers once again. Try to understand the question. Vaishnavi and Sakshi are going for B. What about others? Others? All of you try. All of you try the answer. Two Sanikas are there, no? Both of you try. Two Vaishnavi, Vikas, Mahek, Jyoti, Geeta. All of you try the answers. Good job. C. Okay. So let's do. Let's do. So what they are saying, the rate of the equation is given. The rate of the equation is given. And here, the initial concentration of A is tripled. Tripled means I have to put 3A. So the concentration of A is tripled and the concentration of B is kept constant. So we are not doing any changes to the concentration of B. Now, if this is the case, then what is the rate? What is the initial rate? So here 3 square, 3 into 3 is 9. 9K is not 3 here. I have taken that 3 outside, no? 3 square 9. So it will be just A power 2, A into A power 2 and B power 1. So this is nothing but the initial rate. So the initial rate would increase by a factor of 9. Very easy, na? So the initial rate is getting increased by a factor of 9. Students, can you all able to understand? Only two students have given me the correct answer for this. Sakshi and Rashmi. So others, I don't know why you guys have given option A and C. So now I think you guys have understood, right? Sakshi have doubt. So what is your doubt, my dear? Tell me your doubt. Rutuja and Sanika, Mahek, can you all able to understand the question? And yes, okay. Good, good, good. Okay. So let's wait for the how to find the decrease in rate. Why we are going to calculate the decrease in the rate, my dear? We are going to calculate the decrease, no? So the minus sign is representing the disappearance of the reactant. That is the decrease in the concentration of the reactant. So we don't have any term like decrease in rate. Okay. Decrease. Decrease means we may have minus sign in front. Increase by a factor of 9 means we may have minus 9. But that kind of answer mostly we won't get. Okay. The rate may get decreased sometimes when we decrease the concentration. But here we are increasing the concentration. We are tripling. No, tripling means we are increasing it to 3 times. So we will get the rate with the increase factor only. If we are decreasing the concentration of A to half, then in that time, in some cases, we may end up with minus values. Got it? That too, if you are having the power as 2, we will not get that also because if you power anything, if you square anything, you will end up with positive values only, right? So that is a rare case. Here, the answer for this question is option B. Clear, Sakshi? Yes. The next question is assertion reason type question. Assertion says a reaction can have zero activation energy. What do you guys say about this assertion statement? Can a reaction have zero activation energy? Yes or no? Okay, think of it. And the reason is the minimum extra amount of energy absorbed by the reactant molecules so that their energy becomes equal, to threshold value is called activation energy. What about this is the definition given for activation energy, and think of both the statements and give me the correct answer in the chat box. Check whether both are correct, check whether both are wrong. Is this question so difficult, students? I did not get even a single answer from your side. Yes, students, what is the correct answer? Right? Tell me whether assertion is correct or not first. We will solve this question in the class. Tell me whether assertion is correct. Can a reaction have zero activation energy? Can you have a reaction with zero activation energy? No. Very good. So a cannot reaction cannot have zero activation energy. So at least some amount of energy is required to activate the reactant, then only the reaction will happen, right? Then only the reactant can be converted into the product. Yeah. So assertion is false. Assertion is false. So in only one option you have assertion false. That is option C. So you can go for option C as the correct answer without even checking for the reason. Okay. But for the safer side, you have to check that also. The minimum extra amount of energy absorbed by the reactant molecule so that their energy becomes equal to the threshold value is called as activation energy. So that is the correct statement for the activation energy. So R is true and A is false. Option C is the correct answer. Okay. All of you been able to understand? Do any of you have any doubt from this question? Yes. Okay. So let's move on to the next question now. All of you keep trying, keep trying. Okay, don't stay silent, keep trying for the answers. For a chemical reaction, 4A plus 3B giving 6C plus 9B, rate of formation of C is given as 6 into 10 power minus 2 mole per liter per second. And the rate of disappearance of A is given as 4 into 10 power minus 2 mole per liter per second. The rate of reaction and amount of B consumed in interval of 10 seconds respectively will be. So formation of C and disappearance of A is given. Okay. And time is given as 10 seconds. So we have to find out the rate of the reaction first. Okay. And then we have to find out the amount of B consumed in interval of 10 seconds. So we have to find out two values. So how to find out? So to approach this question, first write the rate of the reaction. The rate of the reaction is equal to minus 1 by 4 dA by dt, which is equal to minus 1 by 3 dB by dt, which is equal to plus 1 by 6 dC by dt, which is equal to plus 1 by 9 dd by dt. So this is the rate equation. Okay. So now we are provided with the rate of formation of C. That is, we are given with this value. So what we can do, we can substitute. So the rate of the reaction is equal to plus 1 by 6 dc by dt. So in place of dc by dt, we can substitute the given value, which is equal to dc by dt is 6 into 10 power minus 2 divided by, we have a 6 in the denominator, put that here. So 6 gets cancelled here and we will get 10 power minus 2 mole per liter per second as the rate of the reaction. So 1 power 1 into 10 power minus 2 or 10 power minus 2, both are correct. So the rate of the reaction is equal to 1 into 10 to the power minus 2. So in which option we have this? So either option B or D should be the correct answer for this question. Okay, but to find out the correct answer from these two options, we have to find out the amount of B consumed. Okay, so to find out the amount of B consumed, take the rate for this B. So the rate of the reaction in accordance with B is equal to minus 1 by 3 dB by dt. So bring this 3 to the other side. 3 into rate of the reaction. 3 into the rate of the reaction is equal to minus dB by dt. So what is the rate of the reaction? 10 into 10 power minus 2. So 3 into 10 power minus 2 is equal to minus dB by dt. Okay. And now we have to find out the amount of B consumed after the interval of 10 seconds. So after the interval of 10 seconds, after the interval of 10 seconds, it will be equal to 3 into 10 power minus 2 into 10. So what is the answer? 3 into 10 is 30. 30 into 10 power minus 2 mole per liter will be the answer. So which is the correct answer, my dear students? Option B is the correct answer. Rate of the reaction is 10 power minus 2. The amount of B consumed is 30 into 10 power. Can you all able to understand this question? So it looks little bit lengthy, but if you have understood what they are asking from the given values, you can approach this very easily. Clear? Clear to all of you? Please actually is giving me the influence. Can others able to understand? Yes. Okay. Okay, my dear students. So now let's go with the next question. So if you are writing the answer, you don't know, you can write. Okay. Shall I move on to the next slide? Have you all completed? Okay. The given graph is a representation of kinetics of the reaction. So the y and x axis for zero and first order reactions respectively are. The four options are given to you. Okay. So in all the four options, the first part is with respect to zero order. The second part is with respect to first order. So find out the correct option from the given four options. So think of the concepts we have studied for zero order and first order. Find out the x-axis and y-axis for each order. Students, not even a single student have Got the answer? Do you feel this question is very difficult question? So I'll do for one, you find for the next. Okay, so I'll do for zero order and you guys try to do for first order. So can we go in that way? Okay. So for zero order reaction, we have studied that rate is independent of the concentration, right? For zero order, what we have studied for zero order, rate of the reaction is independent. Independent of what? Concentration. That is, rate is equal to K into A to the power 0. So A to the power 0 is nothing but 1. Okay. So if I take this y-axis as the rate and x-axis as the concentration, so even if I increase the concentration, the rate is not going to get affected. Clear? Clear for all of you? So the x-axis can be the concentration and y-axis can be rate. So either option C or D should be the correct answer for this question. So now you guys try for first order and tell me whether option C is the correct answer or D is the correct. For first order reaction, which is independent of what? Think of it and get the answer. Think of it and get the answer. So for first order, T half is D. So for first order, half-life, T half is independent of concentration, right? So that is what we have studied now. For first order reaction, the half-life is independent of concentration because T half is equal to 0.693 divided by K. So here we don't have concentration term. So this T half is independent of the concentration. Okay. So if I keep this x-axis as concentration and if I take this y-axis as T half, even if I increase the concentration, the T half is not going to change. It will remain as such. So the given graph denotes option C. The given graph is for option C. Okay. Yes. Option C is the correct answer. Any doubt from this question, students? Shall I move on to the next? So think of the concepts we have studied for each order. If you think of it, so within few fraction of minutes, you will get the answer. So the next question is, for a first order reaction, A giving products, initial concentration of A is 0.1 molar, which becomes 0.001 molar after 5 minutes. Rate constant for the reaction in minutes is. So how to find out? So the reaction is first order, we have to find out the rate constant K and the concentration values are given to us. So to find out the K for first order reaction, which relation we have to use? We have K is equal to 2.303 divided by T into log of initial concentration of A and the concentration of A after some time T. Okay, so substitute all the values. 2.303 divided by T. So what is the time? 5 minutes into log of initial concentration of A is 0.1 and after 5 minutes, after some time, the concentration is 0.001. So 0.1 can be written as 10 power minus 1 and 0.001 can be written as 10 power minus 3. And if I cancel this, I will have 10 power minus 2 in the denominator. If it goes to the numerator, what I will get here? I will have log of 10 to the power 2. What is log of 10 to the power 2? I have already given you one formula, no? Log of m power n is equal to n into log m. So here we have log of 10 to the power 2. So it is nothing but 2 into log 10. Log 10 is nothing but 1. So 1 into 2 is 2. So log of 10 to the power 2 is equal to 2. So we have 2.303 divided by 5 into 2. Okay. So if you multiply and if you divide, what you will get? Can anyone do the multiplication and division part of this question and let me know the answer? So here I will have 2.06 divided by 5. One of you try to find out the answer. So you need to just apply this particular formula. What is the name of this formula? This is the formula we get from integrated rate equation for first order reaction. Okay. We'll get this formula from integrated rate equation for first order reaction. This is to find out the rate constant. Yeah, very good. Option B is the correct answer. So you will get 0.9212 per minute as the answer to this question. Okay. So try to get the given values from the question and think of the formula which has to be applied. So mostly in this lesson will have at least some around two formula for integrated rate equation, two formula for rate constant, two formula for half life. So like this we one for Arrhenius equation. So like around 8 to 9 formulas only we have. Okay, so think of the formula which has to be applied for that particular question and apply that and give the answer. Okay. So we'll move on to the next question now. The slope of Arrhenius plot ln k versus 1 by t of first order reaction is minus 5 into 10 power 3 Kelvin. The value of activation energy of the reaction is. Choose the correct option for your answer. And R value is given to us. So this is a little bit lengthy. So I'll teach you how to solve this. So what is the Arrhenius equation? Can anyone tell me? It is K is equal to A into minus EA by RT. So apply the logarithmic function. Apply ln on both the sides. So ln K is equal to ln A plus ln e power minus EA by R. Okay. So here logarithmic function and exponential function will get cancelled out each other. So write the remaining thing ln K is equal to ln A minus, write the remaining part here, minus EA by R to 1 by T. So now this particular equation is of formula y is equal to mx plus c. Okay. So here m is the slope and it is nothing but minus EA by R. So m is the slope value and it is equal to minus EA by R. So that slope is only given as, the slope of this Arrhenius plot is only given as minus 5 into 10 power 3. So substitute minus 5 into 10 power plus 3, which is equal to minus A by R. So minus minus will get cancelled out each other and keep EA one side and bring R to the other side. Substitute the value of R. R is 8.314 joule per Kelvin per mole. Okay. So, and if you multiply this, what you will get? 41.57 into 10 power 3 joule per mole will be the answer. And in terms of kilojoules per mole, all of you got option B as the correct answer? Yes. So this 10 power 3 can be written as kilojoule. So it is 41.5 kilojoule per mole. So option B is the correct answer. Students, able to understand? So take the Arrhenius equation, apply the logarithmic function and get the straight line equation and relate the slope, substitute the slope value given in the question. Okay? Okay, good. The next question is, If the rate constant for a first order reaction is K, the time required for the completion of 99% of the reaction is given by. How to solve this? So T is equal to, for first order reaction, 2.303 divided by K into log of initial concentration of A divided by concentration after something. So this is the reaction to find out the T for first order. Now for 99% completion, for 99% completion of the reaction, so what would be the value for T? T is equal to 2.303 divided by K into log of. So initially we may have 900 and after some time T, 99% have got reacted. So it is 100 minus 99. 100 minus 99 is nothing but 1. So 100 can be written as 10 power 2. So log of 10 power 2 is nothing but 2. So it is T is equal to 2.303 divided by K into 2. So what is the value? It is 4.606 divided by K. Okay. So the time required for the completion of 99% of the reaction is given by option A. Clear? You are able to understand how to approach this type of question? Do you have any doubts? Okay, clear. So now let's go with one more. Yeah. Here in this question, you're not able to see the options now. It means it is a JE question. So far we have been discussing the NEET question. Now this is a JE question. The question is, if compound A reacts with B following first order kinetics with rate constant 2.011 into 10 power minus 3 per second, the time taken by A to reduce from 7 gram to 2 gram will be. So what is given? Rate constant is given, initial amount is given, and amount after some time is given. We have to find out the time. Okay, we have to find out the time taken by A to get reduced from 7 gram to 2 gram. So take the since the reaction is first order, follows first order kinetics, we have to take the same equation. Okay, T is equal to 2.303 divided by K to log of A naught divided by AT. Substitute all the values. 2.303 divided by K value. K is 2.011 into 10 power minus rate constant. No? So log of, initially we had 7 gram and after some time we had only 2. Okay, 7 by 2. So what is log of A by B? Log of A by B is equal to log A minus log B, right? So no. So log of 7 by 2 can be written as 2.3303 by 2.011 into 10 power minus 3 to log of 7 minus log of 2. So log 7, log 2 values are given in the question. Substitute all the values. 2.303 divided by 11 into 10 power minus 3. Log 7 is 0.845 and log 2 is 0.301. So subtract these two, multiply with 2.303, divide with the given rate constant value, and try to find out the correct answer. So has anyone got the answer for this question? So if you solve this, 0.542 10 power 3 by no, you will get 622.99, which can be approximated to 623 seconds. Okay, so the nearest integer is 623 seconds. Got it? So your answer is more or less closer to this kind of. Okay. What? Yeah. but you have to find out the exact answer. Then only you will get correct mark. So shall we go with the next question? Yes. Okay. So for conversion of compound A to B, the rate constant of the reaction was found to be 4.6 into 10 power minus 5 liter per mole per second. The order of the reaction is. So this is actually a very easy question. How will you find out the order from the given information? So within a few fraction of seconds, you can get the answer for this. We are provided with the rate constant value and with its unit. How will you find out the order? What could be the correct order of this reaction? Very good, Sanika. It is 2. The order is 2 because the unit is liter per mole per second. So mole per liter or 1 minus n per second formula has to be used. And if you substitute n value as 2, you will get liter per mole per second. So the answer is 2. Very good, Vaishnavi. Order of the reaction is 2. So without even thinking of the given number value for rate constant, just by looking into the unit, you can get the order. Okay. So this kind of question is not a time consuming question. You can go for this question just by closing your eyes. Okay. Next, we'll go with one more. For the first order reaction A giving B, the half-life is 30 minutes. The time taken for 75% completion of the reaction is. Log values are given for something. So we have to find out the time taken for the 75% completion. So how to find out? So T half value, half-life is given as 30 minutes. Half-life means if half of the reactant have got reacted, the time taken for that particular process. That is, initially I may have 100% of the reactant. Then it may get converted to 50%. Half of the reactant have got reacted. The time required for that particular reaction is 30 minutes for this half-life. Okay. Now here 50% is remaining and the remaining 50 have got reacted. Now to convert, what is the half of this 50? The half of 50 is 25. Half of 50 is 25 and the T half for this is 2 into 30 because this is the second T half, no? So it will be 2 into 30 means this is nothing but 75% completion. Already 50% have got completed. Okay. Now here 25% have got completed. So totally at this point 75% of the reactant have reacted. 75% of the reaction undergone the reaction. Okay. So the time taken for 75% completion is but 2 into T now, which is equal to 2 into 30, which is nothing but 60 minutes. It's nothing but 60 minutes. So this is the value we are substituting. Okay. So the time is 60 minutes. Clear? Clear for all? Just think wisely. Think once or twice to go with this type of question. The questions will be a little bit tricky, but neat. But you can solve it if you have understood. So the next question is, for a reaction, given below is the graph of L and K versus 1 by T. The activation energy for the reaction is equal to the activation energy for the reaction. So how to find out activation energy? The same process we have to follow. Take the Arrhenius equation, which is K is equal to E power A into E power minus A by RT. So if you apply the logarithmic function, L and K is equal to L and A. And if I apply log to the exponential function, they will get cancelled. So it is minus A by RT. Okay, R means R into 1 by T. So now this is Y and this is M and 1 by T is X and L and K is C. So we all know that slope is A by RT. Slope is nothing but A by R A by R, which is equal to the slope is 20 divided by 5. So this is the slope, right? This is the slope for the entire thing, which is nothing but 20 by 5, which is equal to 4. Slope value is 4. So EA by R is equal to 4. EA is equal to 4 into R, which is equal to 4 into R value is given as 2 calories per Kelvin per. So in terms of calories, the R value is 2. So 4 into 2 is 8 calories per. The activation energy for the reaction is equal to 8 calories per mole. Okay, students, is it clear? So we will go with the one more question, which is the last question for today's session. And after solving that, just uh, just wait a minute second. Just give me a second. So can you able to see the screen now? Yes. Yeah. So this is the last question for today. So try to solve it. So we have a reaction A giving the information of compound B follows the first order kinetics. And after 70 minutes, the concentration of A was found to be half of its initial concentration. Then the rate constant of the reaction is X into 10 power minus 6. So the value of X is the value of X is. So since the reaction follows first order kinetics, we can take the half-life. So after 70 minutes, the concentration of A was found to be half of its initial concentration. So I can use the half-life formula, so which is K is equal to 0.693 divided by T half, which is equal to 0.693. The half-life is 70 minutes. But we have to find out the answer in terms of seconds. So put 70. So each minute contains 60 seconds. So 70 minutes means 70 into 60. Okay. So it is nothing but 6930 into 10 power minus 4 divided by 7 into 6. Bring the 10 power 2 to the numerator. It will be 10 power minus 2. Totally now it is 10 power minus 6. So 6930 divided by 7 to 6 into 10 power minus 6. We will get the answer in terms of 10 power minus 6 here. We need to just divide these two numbers. Can you divide? What is the answer? 6930 by 7 into 6. You can go with 3. 3465 by 7. 3465 by 7. 3465 by 7 is 165 into 10 to the power minus 6 per second. So the value of x is 165. Very good. Students, can you be able to understand? Only if you solve, if you practice questions like this each and every day, with the consistency, you will be able to solve the questions in your examination. Okay. So don't think it is hard and difficult. You can able to do it if you solve it regularly. Got it? So I hope this session is very useful for all of you. And today we are closing this chemical kinetics lesson. If you are having any doubts, you can ask that doubt now. Otherwise, we can meet up with the next new chapter in the next lesson, next class. Okay. Any doubt for anyone? Okay, let me wrap it up the session, students. Thank you so much. Thank you. Take care. Bye-bye.